Today we are traveling through centuries of thought and discovery, from Aristotle and Cusanus to the present, with Einstein's theory of relativity. We'll learn about the concepts of the ether, the infinity of the universe, and the role of astronomy in developing our understanding of space. Let's get started. Outer space, located outside the Earth's atmosphere and between celestial bodies, reveals a fascinating world. From the known laws of gravity to the mysterious aspects of dark matter and vacuum energy, this space is filled with low particle density, electromagnetic radiation, and mysterious cosmic rays. The basic temperature of space, determined by the relic radiation of the Big Bang, is only 2.7 Kelvin, but the temperature of the plasma between galaxies can reach millions of Kelvin. In terms of mass and energy, dark matter and dark energy have a mysterious superiority over the world we know. The boundaries of international space law, established by the Outer Space Treaty of 1967, open the door to research by all states. Despite attempts to regulate the peaceful use of space, the space around the Earth has already been an arena for testing anti-satellite weapons. From the first high-altitude balloon flights to manned rocket expeditions, humanity has been stubbornly pushing the boundaries of its exploratory desire. Despite the difficulties associated with the high costs and health effects of microgravity, people are already exploring all known planets, leaving a trace in the vast ocean of space. 350 years before Christ, the great Greek philosopher Aristotle suggested that nature would not remain empty, leading to the establishment of the horror of the vacuum. This principle was formed on the basis of the idea of Parmenides' ontological argument, which rejected the possibility of emptiness in space. Thus, in the West, it has been believed for centuries that space cannot be empty. Back in the 17th century, the French philosopher René Descartes argued that the entire cosmos must be filled. In ancient China, the astronomer Zhang Heng concluded in the 2nd century that space must be infinite, going beyond the mechanism that holds the sun and stars. Records have been preserved in the Xuan Yi school, which states that the sky is infinite, empty and without substance. Consequently, the sun, moon, and clusters of stars float in empty space, moving or remaining motionless. The Italian scientist Galileo Galilei is known for his significant idea that air has weight, and this weight was subject to gravity. In 1640, he proved that the creation of a vacuum was hampered by air resistance. However, his student Evangelista Torricelli solved this problem in 1643 by creating the first mercury barometer. The French mathematician Blaise Pascal realized that the mercury column shrinks high up, where the air pressure is lower. In 1648, his son-in-law, Florine Perrier, confirmed this on the Puy-de-Dôme mountain in central France. This experiment led to the creation of the first mercury barometer and great scientific recognition in Europe. In 1650, the German scientist Otto von Guericke created the first vacuum pump, which disproved the concept of the horror of the vacuum. He correctly noted that the Earth's atmosphere is a shell, and its density gradually decreases with altitude. He also concluded that there must be a vacuum between the Earth and the Moon. In the 15th century, the German theologian Nicholas of Cusa proposed the idea that the universe cannot have a limited center and circumference. He believed that the universe, although not infinite, could not have boundaries that limit its existence. These reflections served as the basis for the Italian philosopher Giordano Bruno's thoughts on infinite space in the 16th century. Bruno expanded Copernicus's heliocentric cosmology, based on the ideas of Cusanus, by adding the concept of an infinite universe filled with a substance he called the ether, which does not experience resistance to the movement of the heavenly bodies. The English philosopher William Gilbert also came to a similar conclusion, arguing that the stars are visible due to a thin ether or void. This concept of the ether was popular among scientists until the early 20th century. An important stage in the development of understanding of the cosmos was the Michelson-Morley study in 1887, aimed at detecting the Earth's motion through the ether. Despite the zero result of this experiment, the concept of the ether was no longer supported. It was replaced by Albert Einstein's special theory of relativity, which establishes the constant speed of light in a vacuum, independent of the observer's motion or reference frame. The first professional astronomer to support the idea of an infinite universe was the Englishman Thomas Digges in 1576. However, the volume of the universe remained unknown until 1838, when the German astronomer Friedrich Wilhelm Bessel measured the distance to the star 61 Cygnus, finding a parallax of 0.31 angular seconds. This made it possible to calculate a distance of more than 10 light-years. Subsequently, the distance to the Andromeda Galaxy was determined by American astronomer Edwin Hubble and Henrietta Swan Leavitt, which confirmed the infinity of the universe and its location outside the Milky Way. Thank you for traveling with us through the centuries of space exploration. From Aristotle to Einstein, from ether theory to modern science, we have delved into the mysteries of the unknown.